2 times the absolute value of x using transformations. So we're going to graph. The parent function is the absolute value of x. Okay. And this 2 out front, it's a vertical stretch. Vertical stretch by 2. Okay, so just like before, we're going to make 2 tables. We're going to make a table for the parent function. And then we're going to make one for the transformation. So the absolute value function, it returns the positive of the value. So if it's negative, it becomes positive. If it's positive, it stays positive. Hopefully you remember that from class. Is that okay? Is that clear?
Mm-hmm.
Okay, so 2 times the absolute value of x, what that does is it changes the y values. Every y value is multiplied by 2. So we're going to multiply 2 times 2, 1 times 2, 0 times 2, and so on. So each of those y values, you're multiplying by 2. And then this is what we're going to graph. So I would definitely recommend getting the tables down, but for sure you got to get the graph down. Here's your graph.
Yeah. All right, let me write that down. Okay.
You got this down?
Yeah, I got that down.
All right, so now we're going to move on to the next part here, which is average rate of change. Okay, so let me snip that in. And it looks like we got to find the average rate of change between 2 points. Okay, there it is. All right, so let me snip that in. Okay, so the average rate of change, if you remember from last time, it's it's f of b minus f of a over b minus a.
Okay, I have to write it down.
Yeah, you should write that down. Okay, now in your problem, a is -4 and b is 0. So in your problem, you're going to find f of 0 minus f of -4 over 0 minus a -4.
Okay. Okay, so, okay. All right.
Okay, so f of 0, okay, it comes from this function here. So it's 2 times the absolute value of 0. What is 2 times the absolute value of 0?
Okay, yeah. The absolute is 0,
Yes.
0,
And 2 times 0 is?
0.
Good. And then we're going to do f of -4. So that's 2 times the absolute value of -4. What is the absolute value of -4?
Absolute value of -4, 4.
Okay, and 2 times 4 is?
8.
8. Very good. So these two values you just found go in the numerator. The 0 goes in the first position, and 8 goes in the second.
Hmm. Okay.
And then on the bottom, it's 0 minus a -4. So what does this simplify to?
All right, so for that, that's -8 and 4.
Okay, so then on the bottom, what does that reduce to?
There we go.
What does this reduce to?
2, -2.
-2. Very good. Okay. The next thing is they want you to actually graph these, graph this. Okay, so that's just to sketch the secant line, connecting the 2 points on your graph. So the way we're going to do this here, I'm going to graph the absolute value function again that we were looking at. So it's the same as before. Okay, but it actually, it actually extends up here. So you need a little bit more, I don't know, height on your graph here. But this is the graph of y equals 2 times the absolute value of x. And they want you to graph these 2 points, 0, 0, which is already here, and then -4, 8. And they just want you to basically overlay the line there for the second part.
Hmm.
So this sketch is needed for question D.
Okay. Okay. Let me just do this. Let me just write that. Okay, there we go. And it's okay.
So you got that down?
Yep.
All right, now the next question, part E, we have to go back to what we had the other day, but the answer will be that they're the same.
Same. Okay.
Yeah, I don't know why instructor keeps writing why are they different.
I don't either, but we'll just have to just write for what the my teacher says.
The same is what you're going to say. They're the same. Oh, actually, no, I'm sorry. This time they are different.
Different?
Yeah, so if we go back to what you put down in part B, so in 2B, you found that the average rate of change is 2. And in 2D, the average rate of change is -2.
Okay, so I have to write that?
Yes, you'd want to write that. And then we can actually say why they're different.
Okay. So it's okay. So there we go. So why?
Yeah, so now why are they different? They're different because in the first one, well, it's y equals 2x. In the second one, it's y equals the absolute value of 2x. So these are obviously different, but there's a bit more to it. So the absolute value function is actually two things. It's -2x when x is less than 0. And it's 2x when x is greater than 0. And if you noticed, the window that we're choosing from -4 to 0, we're looking at this top graph. So that, again, that may have been a little bit more explanation, but the reason
So
they're
why are they different? They are different because
they're different functions is the
because
short.
because two has different functions.
Yeah.
Okay, so we're going on to number 3.
Yep, we can move on to 3 now. I'm sure it's the same, meaning that it's probably just another, yeah, so it's another thing here. So 3A, we're going to graph using transformations. Great. Okay, so the parent function here, parent function is y equals x.
Okay. All right.
All right, so now we're going to use our basic parent function graph, x, y equals x, and start with this parent function. And this time the y value equals the x value. So then the change, the 1/2, all that does is it affects the y values. The y values are reduced by 1/2. So whatever the y value is, you multiply by 1/2, or you can think of it as dividing by 2. It's equal. So -2 times 1/2 is -1. -1 times 1/2 is -1/2. 0 times 1/2 is 0. 1 times 1/2 is 1/2. 2 times 1/2 is 1. And then
Okay.
we're gonna graph these here. It's still gonna look like a line. I mean, it's supposed to. It's still a line. It's just that it's not as steep as some of the others. So I'm actually going to add another point here just to make it a little easier to graph for me. Okay, so there's your graph there of that.
Okay. Okay.
All right, ready to move on to 3B?
Mm-hmm.
Okay, so 3B asks for the average rate of change. So the average rate of change, again, it's the same formula every time. F of B minus F of A over B minus A. They give you A and they give you B. So you have to find F of 2 and then F of 0. And they give you the function. The function is 1/2 x. So everything is given. You just have to like put the pieces together. So F of 2 means 1/2 of 2. And F of 0 is 1/2 of 0 because our F of x is 1/2 of x. So Sourish, what is 1/2 of 2?
1/2 of 2. Do I have to write that?
Yeah, you should write all this.
Okay, yeah. I'm doing this on my notebook so it can be very better because just for the notebook, it just makes me a lot better to put my things in there.
Good, good. I'm not grading you, your instructor is, so do whatever they want. You know, they're the
Yeah,
ones that
because
are,
an average rate of change, it says show all work in your math notebook.
okay.
Okay, so for that, 1/2, 2,
Yeah.
2 is 2, and then it's 1/4.
Oh, no, it's 1/2 of 2. So like imagine you have two things, cut it in half, you've got one thing.
4 or 1.
One, yes. And 1/2 of 0, if you have nothing, then half of nothing is still nothing. Is that clear? 1/2 of 2
Yeah,
and
there we
1/2.
go. I
Okay.
got it.
Now the f of b minus f of a over b minus a, like we just did that. It's f of 2 minus f of 0 over 2 minus 0. And we just found f of 2. F of 2 is 1. You see, I'm just substituting these numbers in.
Mhm.
And then f of 0 is 0 over 2 minus 0. So what does this reduce to?
1, 2.
1/2, yeah. All right. So let me know when you get that down, and then we'll sketch the graph here again.
I got that down.
Okay. So the graph from the previous problem, it looked like this. I made a couple extra points here. So that's the graph from the previous problem. Now they want us to sketch the line that goes through 0, 0. That's this one right here, and then 2, 1. Do you see how it's right on top of the other? You see how it's just on top? It covers it because it's the same line.
Yeah. Mm-hmm.
So the instructor's hoping you will see that. They're hoping, okay, you'll like get it. You'll say, oh yeah, they're the same line.
Okay, I'm seeing it. I'm seeing it.
Great. All right, so let me know when you get that graph down, and then we'll move on to part D.
Part C.
Part C, yes, we'll graph it first.
Yeah. You know what? I already have my graph on the top already.
Well, you're welcome to just overlay it and maybe just make an arrow to it and say, hey, it's the same graph. It's whatever you think the instructor will accept. Like that's, yeah, they don't give you a ton of room here on this as you're trying to work through it.
Okay, got it.
All right, so I'm going to snip in 3C. Yeah, so again, we're going to graph this using transformation. The parent function is x squared. That's the parent function. You always want to start with that. We'll make a table of that, just like we've been doing. The process is exactly the same. So your parent function is -2, -1, 0, 1, and 2 for your x. And then you put those values into the function on the right, and they all become positive. So now we're going to make the transformation, the 1/2 x squared. So what that does is you take the outputs here and you multiply them by 1/2. So the x values stay the same. In almost every problem we've done, the x values have stayed the same, but the y values, you have to cut them in half. You have to divide by 2. So that's 2, 1/2, 0, 1/2, and 2. Okay, so now we can graph this.
Mm-hmm.
-2, 2. negative 1, 1/2, 0, 0, 1, 1/2, and 2, 2. So it still has this U shape. It's just a little bit wider than usual.
Yeah, yeah.
That graph you want to get down.
Okay.
You got it down?
Yep.
All right, we're ready to move on to part D. And part D is yet again kind of the same thing. It's the average rate of change. The average rate of change.
Okay.
So the average rate of change, let me snip this, get this back here. The average rate of change is, it's the same formula. It's f of b minus f of a over b minus a. Your a is 0, your b is 2, and your f of x is 1/2 x squared. So you first have to find f of 2, which is 1/2 times 2 squared. Then f of 0 is 1/2 0 squared. And yes, you want to get all this down. So go ahead and calculate those and let me know what you come up with.
Okay, I got that down. And now for that, that's 1,
Now you have to square it first. So you do
4.
2,
That's 4.
and then half of 4 is
2.
2. And then you square 0 first. 0 squared is 0. 1/2 of 0 is 0. Okay, so now we're going to use the fact that b is 2 and a is 0, and we're just going to write this in f of 2 minus f of 0 over 2 minus 0. I've mentioned this a few times. These numbers have to match up. 2 and 2 match up, 0 and 0 match up.
Let me write that down. Okay, got it down. Got it down.
Great. So now what is f of 2? F of 2 is, we just calculated. See how it's 2
2.
minus f of 0. F of 0 is 0. We
0.
just over 2 minus 0 is 1. Okay, now we're gonna go back to this graph.
Oh, wait. I need to be able to redo the bottom.
Yeah, go ahead and get this down, but we're gonna go back to the graph above.
Okay, let's get back to the graph.
Whenever you're ready, whenever you got this down.
I'm ready.
Okay, so we're connecting the point 0, 0 on our graph here. Okay, and then 2, 2 right there. So we're connecting these 2 points. See how we're connecting with a straight line? That's part D. That's the sketch, the secant line on the graph there.
So the secant line is that
The red line.
line is that?
It's in red, yeah.
Okay, got that.
Right. So that takes care of C. Now we're ready to talk about part D. E. And again, it asks the same question. Compare the slopes. Are they the same?
Yep.
Are they different? So let me snip this in and then we'll go back and look at them. Oops, why did that do that? Let's do it right there. Okay, so in part B, your slope was 1/2. So in part B, it was a slope of 1/2. And in part D, it was a slope of 1. And yes, they are different this time. And the reason is well, the first one was a graph of f of x equals 1/2 x. It's a line. For the second one, your function is 1/2 x squared. It's a quadratic. And so the reason they're different is because one is a straight line and one is a curve.
Okay, so why is it different?
Because one is a line and one is a quadratic, and the quadratic is a curve.
Okay.
All right, so are you ready to move on to question 4?
Yeah.
All right. So we're gonna do question 4. We're actually gonna find the equation first because that will lead to the transformations.
Mhm.
It's actually almost impossible to do without getting the equation first. All right, so I'm going to help here. This is the vertex. That's really important. What is the vertex? Do you see that?
Yeah, the vertex, I know that. The vertex is
Just asking for the ordered pair.
212. Oh wait, I was so close. It's 112.
112, yeah. Okay.
Two so close.
And then this other point is 0, 10. Okay.
So the transformation. So
we're gonna do those second. So do you remember this equation that I'm writing? Have you seen that before? Do you remember this, Sourish, from sometime in the past, either with me or in class?
I know that that's the quadratic, that's not the quadratic, the standard form.
It's called vertex form.
I was so close.
Yep, vertex form. So the H and the K come from the vertex here. So H is 1 and K is 12. So it's Y equals A x minus 1 squared plus 12. And yes, you want to get all of this down.
Yeah, I need to get that down. I'm writing in my paper right now.
Excellent.
Okay, let me just make that the equation. Okay, what is the transformation?
We're not done with the equation yet. So we have to find the value of A. So let me know when you get up to here so we can continue.
Mhm. Okay, there we go.
Okay, so to find A, we need an X and a Y. Do you see this ordered pair over here, 0, 10?
Yeah.
0 is X and 10 is Y. So we're going to put those values in. 10 equals A, 0 minus 1 squared plus 12. And now we're going to solve for A.
Right. Okay, let me just write that. So we have to solve for A?
Yes.
Okay.
So to do that, we're going to subtract 12 from both sides.
Okay. And that is a
-2
negative.
equals.
I know that. -2
Now,
and then -2.
this is 0 minus 1 is -1. And then when you square it, you get 1. So A is just -2.
Okay.
Now,
And
we're
what are
not,
the transformations?
well, do you have your final equation?
Yeah, I have my final equation.
What's your final equation? Y equals what?
Y equals -2.
Okay, what else?
Y equals -2 plus 12.
Well, no, you have to have this X minus 1
X minus 1.
squared plus 12. This is your final equation. You have
Okay.
to take that value back and you have to put it back in for A.
So you have to take that value back to the A.
Yes. And then you have your final equation.
Okay. So you have to solve A, right?
We just did. That's all here. All these steps are here. That's why I was asking if you'd gotten caught up, because we have to continue working through this to get there.
There we go.
All right, so now we can list the 4 transformations. We needed the equation first, believe it or not. So I'm going to snip those in and we're going to write the 4 transformations down. Transformation number 1, it comes from this -1. It's right 1 unit. That comes from this -1 here.
Right 1 unit. Okay.
The second one, it comes from this 2 out in front, not the negative, just the 2. That's a vertical stretch by
Okay.
2.
Vertical stretch by 2.
Okay, now this negative is a reflection or a flip, whichever word you like, over the x-axis.
There we go.
And then the last one is up 12.
Up 12.
Yep, that's this plus 12 on the right. So to do all of these, just to be clear, all of these come from the equation. I didn't do any of them from the graph. They all come from the equation.
There we go.
All right, so we're gonna do this last part and then we'll be done for today.
The B.
Yep. All right, so to do part B, it's y equals -2 x minus 1 squared plus 12. So to write this in standard form, we have to do the following calculation. And I guess probably just best if you follow along here to do this, but we're expanding this binomial. So you write it as x minus 1 times x minus 1. So go ahead and get these 2 steps down, and then we'll move on to the next one.
Okay, got it down. I got it down. All right.
All right.
So does the y-intercept you've written match the y-intercept on the graph?
We're not done with this yet. We have to actually multiply. So we're going to expand the binomial here. We're going to FOIL. So you get x squared minus x plus 1 plus 12.
Okay.
Okay, we're almost there. We have to then combine like terms, x squared minus 2x plus 1. And then we have to distribute. You have to distribute this negative to everything. So it's negative 2x squared plus 4x minus 2 plus 12. And then the very last step, I know there's a lot here. It's plus 4x plus 10.
Okay, well, I need to write all this down. I need to write it.
Yep, that's all you got to do. And that will close us out. So I'll just wait.
What
for you.
about the does the y-intercept?
It has to be the same. Yes, it has to be the same. That's
Okay.
All right, well, let your dad know we're all done, but ask him if we need to talk. If we don't, I'll just see you next
Okay,
week.
Dad? Yes. He's coming. Thank you, Matthew. I finished
You're
my
welcome.
homework. Thank you.
All right.
Yes.
Hello, hi.
Hi, Dr. Kithari. We got through everything tonight. Finished up from yesterday. I don't really know that I've got much feedback other than that, but if you've got any concerns, let me know. We can talk through them here.
The understanding the concept. This one you had
Yeah,
difficult
I think
time.
I'm understanding that. Okay, I have it in my notebook.
There is a lot of repetition here, but I'm not sure. It's very disjointed. If you were to see the paper that he's looking at, they do the same thing over and over again, but I would have preferred him to do like 1A, 2A, 3A, and 4A over and over again. Like that's the kind of repetition he needs.
Okay.
Whereas this one breaks it up though into these other sections. But he says he understands it. I don't know. I think he does, but I'm obviously guiding through him a lot of this. But it's always the same. It's the same, A, B, C, D kind of steps.
Mhm. Okay. Well, at least he's trying. So he's at least he's finishing the task.
Yes. Yeah. So I guess we'll just continue next week.
Yeah.
And we'll just keep working on stuff here, and hopefully you'll see some improvement in his grade if you're not already.
Yeah. Okay, great. Yeah, thank you.
All right. Thank you. Have a great
Bye.
great
Bye,
night.
Matthew.
Have a great weekend. Bye. Bye, Sourish.